altitude. All right, sounding good. Let's go. Let's do one more check. Okay, hi, my name is Brian, and I'm here to hack on some Rust stuff for Tiger Beetle. Sorry, it's been over a week since I streamed last. I made big changes to my AV setup, so I hope you can hear me all right. And I was just kind of like procrastinating, making it all work with OBS again. Also, a big bout of anxiety. I just didn't want to do this for a week. But now I'm back into it, and I'm back to hack on the Rust client for Tiger Beetle. And again, let me know if you have any problems with the stream or the audio, because new setup today. So on this stream, we've been hacking on the Tiger Beetle Rust client for over 2 months now. Tiger Beetle is a financial database written in Zig, and it's got clients for a number of languages. Java, JavaScript, Go, Python, but we are writing a Rust client. All these clients are bindings to a Tiger Beetle Zig library called TB client. Someday we may do a pure Rust client, but this is a bindings. This is a bindings project, and it's got a lot of very rusty things in it, so a nice bite-sized project for showing off how to do, standard production Rust development. There's FFI stuff, a lot of unsafe considerations here, how to avoid undefined behavior. There's going to be some packaging, build script considerations, integration of Rust into other systems, in this case Zig. So it's, I think, a pretty good learning opportunity. And I say bite-sized, but it's already been over 2 months, and it's going to go to 3 or 4 months probably, all considered. But we are approaching our first PR. The whole thing we've been working on is getting an initial MVP PR in. So let people see the code and maybe try it out for themselves and see what we're doing. And we've been knocking on the door of a PR for several weeks now. I'm just doing some last cleanup before we go ask people to look at it. As I recall, last time we worked on the testing. So we built a little test harness, a custom test harness that runs a copy of the Tiger Beetle server for every single test, things like that. And started writing a smoke test, but we didn't get the smoke test completed. So the goal today is to finish writing a smoke test that, does all of the Tiger Beetle request types. And that, if we can get that done, that'll be a good accomplishment for today. For the sake of the initial PR, I don't think we're going to write a very comprehensive test suite. Probably just do this smoke test and show the reviewers this is the kind of test we can write, and then ask them to let us punt on making a comprehensive test suite until a second PR. We also need to do things like write a little bit of documentation. But basically, we don't need to be done for this initial PR. Just get a checkpoint going and show people what we've got. Okay, so for today, give me 1 second here to mess with my Windows. Let's go ahead and switch over to the code. And I'm going to screw with my Windows here for a second so I can see a little better what's going on. All right, that looks all right. You can see my history here. It's all little meaningless commits. I think since it's been over a week, the thing we need to do is really just catch up with where we were and do a rebase, maybe squash this gross history, just kind of figure out what's going on. So it's been since the 17th. Huh. Oh, no. Yeah. I did something on the 17th. Probably not on stream. Probably just wrote a note to myself or something. It's been since the 11th. So 9 days since we worked on this. What I'm going to do is just go squash this against my latest upstream, and then we'll do a rebase. And I'm not going to worry too much about breaking anything right now. To squash this, I'm just going to reset onto that commit, and then just re-add, and just start this history from scratch. Okay, so that's looking okay. I'm going to fetch Tiger Beetle. And let me know if I forget to switch scenes. It's pretty common that I start talking about code, but I don't actually show you the terminal. So let's rebase onto main. It's probably going to just work. Yeah, no conflicts. I think at this point, we've still not made any changes to any Zig code. Yeah, everything we've got here is completely self-contained Rust project. So let's get going and go rebuild that Rust. And clients Rust. And I'm going to go ahead and do a cargo. No, I don't need to clean. If I had upgraded like the tool chain, then I would clean out my build artifacts. Let's do a cargo check and cargo build. And now our build process for the Rust crate should go and rebuild a Tiger Beetle. So once we get to the, so you can see right now it's doing the Tiger Beetle build. This is running the Tiger Beetle build script. And part of that is running the Rust build script. We'll go find the Tiger Beetle source code, up the source tree and go call into the Tiger Beetle build system to build it. It doesn't really output any status information about that, but it's doing it under the hood in this, somewhere in this step here. And now we can go run the test suite, and this should run the one test we have written. Okay, you can see it did something, and it also ran several other sets of tests. So before we get going with our development for today, we're going to figure out what command we need to just run our one test suite that we're working on, which is all this stuff running Tiger Beetle, the server. So we need to identify which test we're using. And I think I called it tests. So it's cargo tests. Yeah, there we go. So we're just going to run that command over and over today as we develop our test. Let's go find our test suite. Tiger Beetle source, clients, Rust, tests. And give me 1 second to sneeze here, literally 10 seconds. Well, I didn't actually sneeze, so I saved that sneeze for later. It's still coming. Okay, let's assess where we are with these tests. So here's our little test harness. This is a custom thing we spent, a whole stream writing that, let's see what it does. Let's refresh ourselves. Create a new test harness. We do this in every single unit test or integration test. It goes, finds our manifest directory and then figures out where Tiger Beetle is. Establishes a work directory where we can put the database. Creates a test-specific port number. And then we have a prepare database step. Where is that called from? So we prepare database and then serve the database. Our test harness contains a temperature and a handle to the server. Yeah, and then when we're done with the server, we just violently kill it. Tiger Beetle will recover from anything you do to it, so you can just send it a kill signal. All right, and here's our smoke test. Okay, so we explicitly prepare the database and then serve. For the purposes of a test harness, this could just be one step. We don't really need to repeat all these commands all the time. Anyway, it's good enough for now. So here's our test, and we've got a bunch of steps here. We're just doing all of the request types. So we've done create accounts, create transfers, 2 different lookups. So these are point queries. Yeah, they're just looking up accounts and looking up transfers, specific accounts and specific transfers. And this is a range query here. It's getting the transfers for an account based on some filter criteria. All right, so Tiger Beetle is not like a general purpose SQL database. It's very specifically designed just for, what do they call it? A 2-sided transaction thing. I'm not thinking of the term right now. I'm not an accountant still. I'll never be an accountant at this point in my life. Not that that's my desire, really. There's kind of, it's always kind of tough to like work on a project where you don't really know the domain. Both like, technically difficult because you don't know the subject, but that's part of the job is figuring out, learning the subject. But also I don't have like a use for a transactional financial database. So it's, a little disconnected from my everyday experience. And I've always found that's kind of like a risk for developers and for projects. Like if the developers don't have like some kind of like connection to the domain, then it's much harder to be passionate about it. But I actually really like Tiger Beetle, even though I'm not an accountant and I don't have a current need for this kind of a database. Anyway, that's a big digression. Let's go see what other things we have to write. So this smoke test, we're just doing all the types of queries, all the types of Tiger Beetle requests. Here's our to-dos. This is all we want to accomplish for this. I think I don't want to do the generated README. Sorry, I'm just digressing a little here. These are other things we probably need to do. All of the clients in Tiger Beetle have READMEs that are generated through code, and those all feed into the website. For the initial PR, we're not going to really want to put this on the website probably. So I'll just write a temporary README that explains that this is an experimental project for now. I'll go ahead and commit that. So that's interesting. And let's go look at our request types. So last one we do is get account transfers. Get account balances is the next thing. So we can more or less crib off of what we've already done here. And in fact, I'm just going to literally copy this whole block of code here. And this is going to be get account balances. And I think this takes an account filter. And so here we can probably use this same filter. I got to kind of refresh myself with the state of this test database we're making here. So we're going to look for balances for this account, and I think that's all we're doing here. We're saying limit 10, but there's definitely not going to be 10 of them. And here we're saying we expect one result, and that's going to depend on... Okay, remember this account balances is for historical balances. We spent like 2 hours one stream just figuring out why we weren't getting results from account balances. And that's because this query is for finding historical balances. And if you don't turn on historical balances, you don't get historical balances. So that means we're going to have to go up here and make a flag, probably for, oh, turn it on for both accounts probably. And to do that, let's go look up the account flags. So here, history. We need that history flag. So for account 1, instead of doing the default flags, I think we can say history. And we'll do the same thing for both accounts. I'm a little hot in my cans right now. Give me a second. Check 1, 2, check. Oh, whoa. Wow. Check 1, 2, check 1, 2. Check 1, 2. Wow. My new monitoring, I have new hardware just for monitoring. So I can monitor several different streams simultaneously. And it's very sensitive. I'm on like, I just turned it up like a millimeter. I turned it down at like a millimeter. So probably not everything is calibrated correctly. Okay, we got history turned on here. Let's go back down and see. Let's try to think through what we think this number of results is going to be. I suspect we're going to have like a balance when the accounts are initially created. So there's going to be an initial balance probably. And then we create one transfer. That's probably going to create a second balance. And then that's all the transactions. So I'm expecting this to be 2. We'll see if that's correct or not. That's not the right test. Down here, this one. We expect 2 balances. And this is not transfers. We're looking up balance is. So I'll say this is res balance 1. And I'm just kind of like imagining how I think this works. And again, I don't really know all of the semantics of Tiger Beetle. I'm not that familiar with it. So I'm just kind of like guessing what I think this test is going to do, and then we'll confirm that when we actually run the test. So we're looking for balances. So let's look up the struct balance, struct account balance. Okay, so there's debits. I think we're not going to have any pending debits and credits, but we will have posted debits and credits. Give me one more second here to mess with my mix. Check, check, check. Oh, that's so annoying. I'm going to have to do something different here, but can't do it on stream probably. It's just too hot. The signal's too hot. I can't get it any lower than it is, and it's a little annoying. I'm just kind of screaming in my head. All right, so we're going to have balance. Let's just redo all of these assertions. Res balance 1 is probably going to be something related to, oh, it should be 0 because we start with, when we create it, we have no credits or debits. So there's going to be a balance of 0. Debits posted. Credits posted. And is there anything else we want to assert about? It doesn't look like it. If we look at account balance, there's nothing else in here really. I mean, we could assert about pending, but our tests here don't really need to test the database itself. We're really just testing that our client works. So So balance 2, we expect to have the debits and credits changed. So if we look at our transfers, did we, oh, 10. So we debited 10 from account ID 1 and credited 10 to account ID 2. So account ID 1 is this one. We're looking up account ID 1. And I think we said 10 debits. So I think that's the whole thing. And then we could do another lookup for account ID 2 here if we really want to. Let's see if this works. Really quick, we debited 10 from balance 1, I believe. Let's confirm that. So transfer, we debited 10. All right, let's run that test. I finally got access to the Tiger Beetle YouTube channel this week. So I've been promising to upload all these past videos for a while now and finally have the access to do it. I've had to cut the videos a little because I have that 10-minute intro card. And I don't want to put 10 minutes of basically nothing on YouTube. And it hasn't really worked out the way I thought it was going to. Because I knew I had to do like a lossless cut on a keyframe. I don't know a whole lot about video editing, but I knew I had to do a lossless cut on a keyframe. And those keyframes appear in almost random places in the stream. So when I go do the lossless cut to trim 8 minutes from the front of these videos, it just kind of appears in like some place. So they all are kind of cut differently. And I guess I could do a lossy cut, but I don't feel like that's the right thing to do. It would be nice if I could like send a signal to OBS, like insert keyframe now or something like that. So I get a perfect keyframe exactly where I want the final cut video to start. It's messing with my specs. Sorry, y'all. Okay, so something failed here. Line 243, our assumptions were wrong. Okay, so there's only one balance. So it must not create. Yeah, I don't know much about video editing, Jay. When I started this, I just started streaming recently. Just kind of like as a personal growth goal. And it's been fun, like learning how to do it and it's been fun buying all the stuff and doing all the setup, honestly. But I had to make that intro video. So I have a pretty elaborate intro video. And so I learned a little bit of DaVinci Resolve. And it's one of those pro applications that like could take you 10 years to master. And I don't think I'm really going to dive into video editing. I'm already kind of on the back end of this life and I don't have enough time left to become a video editor. All right, so I think I am basically wrong here. That must not create an initial balance. Like you create an account, there must not be an initial balance tied to that account until you create a transfer. Let's assume that's true. And then we'll say there's only one of these. And then actually, these assertions I made were for the state of the world after the first transfer. So let's just see if that works. Sony Vegas, huh? Man, like 20 years ago, in a different life, I was into both audio and video production. And then I took a break as did my money-making career thing. But I loved Sony Vegas and Sony Acid, I think, like Vegas and Acid. Acid was for like loop-based audio programming. And both of those suites, I remember Vegas being very easy. And I really miss how easy that tool was. I don't know, is Vegas still around? Okay, so my assertion here, what do you do, Jay? My assertion here was wrong. So apparently this first balance reflects the state of the world when the count is created, which is kind of not at all what I expected. So we only got one result. We asked for maybe 10 results and we got one result. And that result seems to reflect the state of the world on initial creation, not after the first transfer was submitted. So that's annoying. I thought this was going to be easy peasy. Wait a minute. Okay, so what I said here was, so the test still failed, but seemingly in a new way. Maybe I got the credits and debits wrong. I hear you, Jay. I am also a senior engineer. All my career, I've never felt like programming was engineering, at least not the style of programming that I do. I think of it more as a craft. I'm an engineer. Yeah. I don't think at this point I'm ever going to become like a senior anything at any company. Like I've kind of left the corporate world at this point. It doesn't seem like I'm going to go back. I don't really have the fire necessary to succeed in business anymore. So I don't think I'll ever have I may never have a job title again at this point. I'm just like some guy who programs and sometimes get paid for it. All right, so 247 left 10. Let's see where we are here. Line 247. Debits posted 10. Oh. All right, so I've definitely like screwed up by just distracting myself with chit chat here because I made multiple assertions about the same balance that are not compatible. So after the first transaction, we think balance 1 is going to post 10 debits. This should pass. Okay, this passes, but it kind of confounds my, I guess it's just true. Like only transfers, that makes sense. So only transfers trigger update of balances. That makes sense. It could also make sense that there's an initial balance, but that doesn't seem to be the case. There's no initial balance when an account is initially created, even though like you started out with, this might not even be true. It might not even be valid to create an account with initial debits or initial credits. So one of the things about Tiger Beetle is that the data structures used all throughout the stack are kind of shared and it's a very flat abstraction. And so this is the representation of an account table in Tiger Beetle, and you use it all up and down the stack for various purposes. But in some cases, like some fields are reserved or not allowed to be filled in a certain way. Like the timestamp, for example, is reserved for the server to deal with. And so it might just be that when you create an account, these debits and credit fields are required to be 0. You might not be able to seed it with an initial balance. I don't know. But that would explain why we don't see the initial balance show up in the historical balances. Anyway, that's good enough for a smoke test of that. Let's move on to the next one. Hey, X message. This is the Rust client for Tiger Beetle, yes. So we've been streaming this project for 2 months now, and that's been a long time for some. And it's taken a long time because we've done the whole thing on stream. But eventually, sometime soon, Tiger Beetle will have a production quality Rust client. Right now, we're just kind of working on the initial MVP. Not going to be production quality quite yet, but I'm pretty happy with how the API looks at least. Our goal here has been so far to get an API that feels rusty, idiomatic. And internally, it's quite inefficient. But that doesn't worry me too much. Anyway, let's move on to the next type of request. So let's go over to our lib file in the right-hand side and look through our requests. And the last one we did was get account balances right here. So the next one's going to be submit query accounts, and it's another range query. It's a different type of range query, as I recall. The semantics might be slightly different than the previous range query, but still just a range query. But since this is a slightly different type of query, I'm just going to start over and type the whole thing out. Yeah, that's right. If this thing, it'll probably be usable in production pretty soon. Like in the initial PR, someone could use it, but there's going to be a lot of polish not done. Like I expect it to be functionally correct. Like the actual API surface area is pretty low. And while it is true that like oftentimes when Rust compiles, it's correct, this project is a big FFI thing though. So it's purely bindings to the TB client Zig library. And we have run into a number of sort of unsafe bugs, some of which were actual crash bugs. So there's always the risk there that I've overlooked some kind of weird FFI related thing, but I'm pretty confident that this is kind of just going to work. And that's kind of why I'm not really too concerned about writing a really amazing test suite for this, because just the scope for screwing up here is pretty low. When we do a pure rewrite in pure Rust, there'll be much more likelihood of messing up, and we'll really need a comprehensive test suite to do like A/B testing between the pure Rust client and the bindings client to make sure they behave exactly the same. But yeah, this project is quite simple, and the fact that it's taken over 2 months now is a little embarrassing. But I haven't been working on it like nonstop. All right, let's go on and do something. Submit query accounts. And this is going to be something that needs to be awaited. And this takes one argument, which is a query filter. It's different from previous tests where we used an account filter. And we need the definition of query filter for this. Hey, chat, tell me real quick, how loud is my keyboard in your audio? Because like I said before, my monitoring is a little too hot for me. And right now I'm just hearing clicky, clicky, clicky everywhere. I've got a very clicky keyboard here. All right, so we need a query filter here. And we don't need any of these pubs. Also, I hear a lot of plosives and breaths from this microphone, which usually doesn't bother me because I have my monitoring lower. All right, and these we just got to fill in, and I got to think. I actually have to use my brain for a second here and understand what the semantics of this filter are. So we're just looking up accounts. Go back over to the submit query. Yeah, I think, Jay, like in some cases, a little bit of background clicking is actually kind of like pleasant noise. I don't generally mind clicking that much. Submit query transfers, query accounts. So we're going to get accounts back. So we're looking up accounts based on user data or the ledger or the code or these timestamps. I think we can just look it up based on code because we've set the code. So let's make these 0. And really, we should probably write at least one more test that does a little bit more complicated queries here. Let's see, I think we have a variable for ledger. Yeah, we do, right there. Ledger and code. So I could put, for example, different user data. And why don't I do that? Why don't I do a more interesting query here? Just to make sure, just to flex the system a little bit harder. So let's take account 2 and give it a user data 32 of 2. User data 32 of 2. And I wonder if I should give that a variable because it's just kind of a random arbitrary number. Account ID 2, user data 32. Let 32 gross. We'll give it a unique integer here compared to all these other things, just in case we see that number somewhere that we need to debug. All these are different numbers. Yeah, I've been thinking about getting, just for the purposes of streaming, a less clicky keyboard. I'm not really attached to keyboards in the way a lot of programmers are. This one does feel good though. All right, so we need our user data 32 is account something. Let's see if we can get Emacs to, there we go. ID 2, user data 32. That looks, so, oh no, we haven't filled all this stuff in. Code. And this is, I think we call default on this. And these timestamps, when you set 0, that means these are out of play if they're zeros. TigerBeetle relies on a lot of sentinel values like that. I'm going to default these flags. Maybe. Let's look at the query filter flags. And this needs to be all prefixed. We're using everything in the TigerBeetle client. We're prefixing in this code with TB::. Pretty common practice in Rust. Just like this is the thing we're using a lot. We're not going to import all of it. We're just going to give it a nice succinct prefix. Okay, all this stuff needs to be prefixed with the right module / namespace. And let's look at those query flags. Struct, query filter. Okay, reversed is the only one here. And we need to give this a limit, so let's say 10 again. And again, from previous streams, we learned that these limits are specific to every query. They're kind of, Zig uses comp time to calculate the maximum number of these data types that will fit into a packet. And so these limits are hard-coded for every single query. And it's just a number you got to know. And right now we're not exporting those constants anywhere. Although you can put a limit of less than that maximum limit, but this number is going to be something just unguessable, completely unguessable. All right, that's good enough. Let's assert that we're probably going to find one account. Res then is going to be 1. And then let's get the account out of that. Just the one account. And we can just assert the account ID probably. Res account dot account ID. Is that the right field? What data type is this that we're looking at? Query accounts is probably, yeah, a vector of accounts. Struct account ID, not account ID. And the account ID is going to be account ID 2, I believe. And I've screwed up my indentation here. That looks similarly formatted to the previous things. Let's run that test. Yeah, that syntax is not right here. This is where the famed turbofish comes into play. The declaration syntax for this generic type looks like this, but for grammar reasons, when you actually call this a thing on this, you got to do that. And that is the famous Rust turbofish right there. But we don't need to do this because that 6 is going to be inferred. Okay, that all works. Checkpoint our history there. Go on to do another one. And this was submit query accounts. Next one is a similar one, but for transfers. So I'm just going to copy paste this. And again, this is just a smoke test. As far as test goes, this is a pretty darn long test. It's not testing one thing, but it's just kind of like a very broad test that's testing the whole library, that it basically works at once. And then as we continue development, we'll make sure this thing just continues to work. And we'll add some more interesting tests later. All right, so now we're querying transfers. Query filter is the same input. So we can probably just use the same user data. And then this is going to give us, though, transfers, not accounts. So we're kind of like looking up transfers for accounts that have this property. So I think that means we want to, well, let's go look up the, remember we have one transfer in this state of this test world. And it's going to have ID. I don't think we know that. Do we know that? We do know that. That's the transfer ID. So we create our own transfer IDs as clients of TigerBeetle, which is kind of interesting. I don't know if there's situations where TigerBeetle creates its own IDs. I'm sure there must be for some types, but when we create a transfer, we tell it what the transfer ID is. And I'm sure that's for integration into other systems. But that means you also, the client has to know how to generate unique IDs. But you're like your account database lives elsewhere. It's not in TigerBeetle. And your transfers, though, is kind of the domain of TigerBeetle. Anyway, I'm just speculating. I don't really know anything about how people actually use TigerBeetle. So this is going to be res account ID is account transfer ID 1, I think. I talked too much and forgot what I was just reading. And that's probably all we really need to look up here, or all we need to assert here, that we found the thing, the one thing we found it. And this is not account, this is a transfer. Let's run that and see what it does. Let's play some music. I need to come up with things to do, like a bag of things to do when the world stops for compilation. Right, we don't actually need music. Okay, we were wrong. I was wrong. Oops. 292. So I said there was going to be one transfer. Said there was going to be one transfer. I'm wondering, let's see. Yeah, so I said 1, but the result was 0. And I'm wondering if this query filter, I was continuing to think this was like an account filter, but it might be the query filter is actually filtering on, I mean, it probably is the case that this query filter is filtering the transfers, not filtering the accounts, and finding the transfers for those accounts. So this user data 32 is probably not the right user data. So we can go ahead and make it just another one here and say transfer ID 1 user data 32. And then when we create that transfer, we can give it some special user data. Transfer ID 1 user data 32. Transfer ID 1 user data 30 equals 5. Give it another unique number. This is going to work. That worked. And interesting, the compilation time was very fast that time. It didn't need to recompile much. Okay, is that all of the query types? That's it. So how many query types do we actually have? I think it's 8. 1, 2, 3, 4, 5, 6, 7, 7. That can't be right. It must be 8. I must have miscounted. It would be nice to have to pull up the Rust docs or something for this. Or just have outlining in my editor like most modern editors do. Okay, so let's checkpoint that. And that's enough for this test. So we've accomplished that. I'm going to go back to my notes here. So we created that test harness. And I don't have like a to-do here for creating tests. But I'm kind of feeling like this is enough to submit for review. And we'll follow up later with more interesting tests. Okay, this is the big thing that we really got to get done. So far, for the purposes of prototyping, I've used very simple error handling, where I'll show you here. On the right-hand side, this result here. Oh. No. Yes. I'm confused by what I'm seeing here. There's multiple potentials for opportunity for errors here. So this result is an anyhow error. And I kind of regret that I just imported as any as a result here. So for the most part, we're using anyhow results for error handling. And anyhow is a simple error handling library in Rust. It just makes all errors compatible, converts specific errors into general existential errors, and it makes errors easy to think about and not get in your way while you're doing development. But what we're doing here is developing a library with an API, and the underlying protocol has very specific errors for very specific circumstances, and we need to float that all the way up. So using anyhow in this API is not going to be really acceptable. And when I said I kind of regretted using this import result here, it's because I usually rename this. So it's a very common pattern in Rust to take this result type, which represents either a success or a failure, and kind of rebind this name to be module specific. And I'll show you here. It's common to say type result equals result of, this is the OK value, the OK type, the result of T my error. So in your module, every Rust result will have this error type, but it might have other OK types. That's a very common pattern in Rust. But it does get confusing because when you see right here, like in this signature for create accounts, there are 2 results here, and they're actually 2 different types of results. So this inner result here is a standard Rust result where the error type is create account result. So that's a specific error type. But then this outer result, you can see if you can parse this in your brain, it does not have the second type parameter. So that is this anyhow result that is defined something like that. In fact, this is defined as anyhow error. And so when I use anyhow, which I do almost all the time, I usually say result as any result. Like, it's so common for me to use anyhow that I just really want those types to have visually distinct names. And this is part of the reason, because this is not obvious. I mean, for knowledgeable Rust programmers, it's pretty obvious, but it's a little confusing. Anyway, I think what I'd want to do now is let's bite the bullet and get rid of anyhow here. And I think to start, I do want to replace all the uses of the anyhow result with any result. And then we can sort of grep for that as we replace them with more concrete result types. So let's just see what the compiler says about this, because there's probably going to be a bunch of errors now that this is renamed. Oh, and I can say, I can do a type check here. We're going to be doing a lot of just typing at this point, refactoring and typing. We don't need to actually run any code, so we can run cargo check for that purposes. a Rust development workflow is very heavy on running cargo check to just do type checking. On this stream several times, I've spent hours just type checking, not actually running anything. Sorry, I'm confused at the behavior of my pager right now. I'm just distracted by the paging. Okay, so it's going to tell me exactly everywhere I need to change the result name. Line 590. This is an any result. Line 620. Any result. Line 49. Line 71. This one. And I already know all these methods. That first result in the return type needs to change. So now I'm just going and changing the name of result to any result. And then we'll probably spend an hour or more just getting rid of all of them. That is also an any result. Okay, let's see what the compiler thinks now. Oh, that's it. And now what we're going to do with these results is we're going to turn them into very specific results, and we're going to need, probably going to need this error. And we're probably going to need to read a lot of docs during the next section of the stream, because I don't know everything about how this error, I don't know much about how this error works. And this error here is not a type, this is actually a macro, a derive macro. So this error is going to let us derive kind of a thorough type-safe error handling patterns and types. Almost nobody handwrites error types in Rust. It's just too much boilerplate. Almost everybody uses anyhow or this error as appropriate. Just going to compile that real quick to make sure that error name doesn't cause any conflicts. Doesn't look like it will. This is a very fast computer, y'all. Look at this. It's a very fast computer. And this is a very small Rust project. And I think I have mold set up too. Yeah. We spent 30 minutes or so on a stream a couple weeks ago setting up the mold linker. Sorry. Just spinning. Brain is spinning. Don't remember what I'm doing right now. Right. We got to go find a result and replace it. So probably what I'm going to do, I'm thinking about how I want to do this, like top down or bottom up. Top down, we go like pick one of these and replace it with another error type. Bottom up, go down here to these helper functions and look for any result down here. Like we'll probably need these to work before the surface level API works. In the way that the question mark operator works in Rust, like these dependency functions, we can make these more specific than question mark will just convert them to any results automatically. So probably the thing to do is like make this a concrete error type first. So let's do that. First, I think what I'm going to do is just kind of like identify where the errors are here and just kind of think through what's necessary and not lean too hard on the compiler. And it looks to me here like there's essentially one place that returns this function, except this question mark operator does an early return immediately right here. So before we do this collect results function, we actually need to dive a little deeper and find this handle message function. And these are all just like very generic functions that are shared by all these different request types. We spent several streams extracting these and dealing with these generics. And I've complained many times about this. This is a little embarrassing, but It works. Hard to read this, very hard to read. This week I've been working on some side projects. I'm just gonna, give me a second here. I'm tired of staring at code. I've been working on side projects a lot recently, actually staying up till like 6 a.m. almost every night. It's bad. But I was working on a project right now that's kind of like a toolkit for multimedia application development. And one of the signatures, like the signature for like running the main function in this project I was doing, was just the ugliest thing I had ever seen. I'm bored. I'm going to sync it and I'm going to show you what this type signature was. I was thinking, like, as I wrote it, like I stopped and like I stood back and I looked at it and I was like, who can I tell about this? I want to show somebody this type signature that I just wrote. But I didn't have anyone to tell. It was 6 a.m. But let me go ahead and just check it out, and I hope you'll forgive me my digression. But it's my stream, I can digress. Create a new TMUX session for this. I don't think I have it on this computer. This code is not public, unfortunately, yet. It will be at some point. I used to make everything public immediately, but I don't know. A lot of it I just don't want to talk about. Oops, what's that? All right, oh, here it is. Look at this thing. So when you use this library, you call this run function, and you pass it, a thing. This is a runnable thing, right? But look at this. This is a heck of a type signature. This is like all the worst parts of Rust all rolled into one thing. Hard to even comprehend what this is. I mean, like, you can kind of get a sense of it, but oh my gosh. Hey, thanks, X message. I was doing a whole thing here and I screwed up the OBS scenes. Anyway, this is it. This is the entry point to this program, and you call it and pass it this, which is kind of like your main function. And this is a async framework, so everything's going to be a future. And what this does is basically it is a function. So when you run your program, I can open up a example of how it's used. Here is where it's actually called. Like, it looks so innocuous from the outside. It's like, okay, that's pretty simple. But to actually make that work, this is the function signature. And honestly, this is kind of emblematic of async Rust programming. Like, at some point, you got to dig really deep when you're doing async Rust. And I pity programmers that have to learn this, because I've been doing Rust for a very long time. And only like recently have I really been feeling like I actually know how to solve most of the type system problems when writing async Rust. Oftentimes Rust is like a puzzle. It's a type system puzzle. And that's kind of what I've always liked about Rust, is that like you spend a lot of time just like thinking hard about types. And then once they all fit together, it mostly just works. But this type system puzzle is brutal. This is pretty nasty looking. Anyway, I'll explain what this is, kind of. And again, we're just digressing. This is not the project. This is just some other personal project. Essentially what this is a function. This is a closure that takes a thing that the runtime is going to pass into it. But this is a closure that returns a future. But because this future has to be generic, and we don't have like a real way to specify in this position, like this is just an impl future, we have to make it sort of an existential future that is boxed. So the compiler doesn't know what type of future this is. It just knows that it's a box of something dynamic that can behave like a future. That's what this dying future is. And then the box is to put it on the heap so that it has a known size, the size of a pointer basically. So all of this is the future returned by a closure. And this lifetime here specifies that the future that your closure returns is allowed to capture this init type, init value that the runtime passes into your closure, and that this lifetime is not attached to the original run function. It's attached to something that the runtime is going to provide you, this for tick A. And I don't remember what this is called. It's like a higher order lifetime. And this lifetime is not attached to the stack out here. It's attached to the stack inside this call to run. And this stuff right here, these higher order lifetimes I've kind of learned like in what situation you need to do this, but this is very advanced type system, very advanced type theory stuff that I don't really grok. Like I kind of just know that like, well, this lifetime, it's not defined out here. It's defined internally somewhere. So it's going to come from inside the call to run, or not this run, but the call to some run. Oh, the run that is calling this function. Wait a minute. I'm really confusing myself. This call over here. So this is calling this function and passing it this higher order closure lifetime future thing. And then this run function is going to call this, and this lifetime doesn't live outside this function on the stack. It lives inside this function on the internal stack. And that's why you have to use this higher order lifetime syntax that is just brutal and ugly. And I never remember where that lives. They just put a for tick A somewhere, and then the compiler tells. Literally, when I wrote this, I put it out here, and the compiler said, nah, that's wrong. Put it over there. So nobody can remember this stuff. And this dynamic future type captures that lifetime, and then there's some other bounds on the closure. So this is a bound on the future. These are bounds on this closure because the closure is going to be sent to another thread, so it's got to be send and generally tick static for sending things. Anyway, I'm glad I could share that with y'all because that's kind of like the worst of Rust. I mean, it definitely gets worse, but that's bad. That's real bad. Okay, let's stop goofing around. I need to accomplish things. So we said, again, to recap, we're converting these very simple error types to type-safe concrete error types. And it looks like handle message is kind of like the bottom of our stack. So we need to go do this first, and then it will trickle outwards to the external API. In what cases does handle message need to return an error? I'm kind of seeing, here's one case where it returns an error. And this error is probably supposed to be this TB packet status. So probably what we're missing here is an error type called TB packet status. And we've got similar definitions to these already. So I'm going to go put handle message over on the right-hand side here for reference. But if you look at, for example, here, no, not that, not found. This, create transfer result right here. This is a Rust redefinition of a Zig Tiger Beetle error status enum, basically. And so because this is returned already in Rust as an error variant of result, I'm wondering if I've already used this error to create all the boilerplate around create transfer results. And this is probably, a thing for us to crib off of right now. So let's go look at enum create transfer. Oh, interesting. This does not derive error yet. Oh, this one derives error. So in general in Rust, if you're returning an error type in a result error variant, almost without exception, you want to derive all the appropriate error traits because it'll make interop much more convenient. If you don't derive the standard error trait, callers are going to hate it every time they deal with that API. And this is used as an error type, and I have not actually derived this error for it. So I think the first step here is actually not to mess with handle message yet. It's to go make this thing a proper error type. And you can see here, I kind of like what I've done here. So earlier in this stream, I imported this error, but I think this is more explicit. So I'm going to I like this syntax here where we prefix it with the proper namespace. Error is such a common type name in Rust that you never know what error you're looking at. So I'm not going to do this. I'm going to go down to all these structs and just apply this error as a derived to them. So it looks like we have two here, create account result and create transfer result. And sorry, in my head, I'm just wondering how some of my existing test code has worked without this actually implementing error, but not important enough to go deal with right now. So this should be all we need in this case to make this type behave like an error. Let's just go check that and see if it works. And I was apparently wrong because we haven't told this error how to implement display. It needs some extra annotations to understand how to do a display, I think. And I'm just kind of panicking internally because I don't remember how to tell this error how to do that. I don't think I know normally we can't just derive display like that. There's probably some other annotation for this error to tell it what we want to do to derive display. Display is just the Rust trait for converting to a string that will be presented to humans. We need to go look at some docs though. All right, I've switched away from WSL. Let's remind ourselves that when we go back to the code, that we actually need to switch OBS scenes and show you the code. Chat, you got to keep me honest because you know I screw this up almost every time. All right, here's this error. Okay, so this is it. So we actually need to, this is gonna be a lot of data entry, y'all. So to make this display, which you have to do in order to be an error type, implement the error trait, we need to tell it like a string to print for every single variant. I was kind of thinking in my head, I don't know why I was thinking that it would just generate strings like this, but that's only for debug. So in debug mode, it might just say like, sure, I'm just going to splat out the ident for invalid header in this case. But for presenting to a human, this error is not going to accept something so sloppy. So we need to write human words for every single variant. So remember this annotation, error something. In fact, I will go ahead and copy this and put one in place so we can remember, switching back to WSL. So we need to do something like this for every variant. Oh, I'm not looking forward to this. I mean, if it was off stream, like whatever, but it's going to be 30 minutes of thinking of human language to describe all these variants that I actually don't know what they do. And really, we don't want to do shortcuts here. Like we could do something like link event failed, which doesn't really add any smart context to what this actually means. But we do have to make this an error. What I'm wondering is if these have textual descriptions written anywhere in TigerBeetle. Like if somebody else has written a description of these, it really would be kind of a maintenance mistake to duplicate them here because they're gonna drift over time. So what I think I want to do is go look up the TigerBeetle definition of create transfer result And then maybe look through the docs and see if the docs describe what all these mean. But this is pretty gnarly, honestly. All right, let's figure out where this create transfer result is and where it might live inside of Tiger Beetle. I'm just going to grep for something and hope I guess the right name. I'm going to say create underscore transfer underscore result. Nope. All of a sudden I'm doubting myself about what the actual Tiger Beetle style guide is for identifiers. Maybe it doesn't have any underscores. Oh, I'm in the wrong directory. It would help if I was in the right directory. RG create transfer result. There's something. That's still not it. This is something in the REPL, not the actual type of this thing. But maybe if we say, give me some more context, we'll see some type spelled out here. Doesn't really look like it. Let's go look in the state machine then. Oh, of course, this is a type name, not a function name. In Tiger Beetle, the convention is whatever this is called, camel case, or camel case, I think this is. There we go. All right, something in here. I'm going to say type zig. I don't care about all those Java files. This is it right here, tigerbeetle.zig. So tigerbeetle.zig defines a lot of the core types for the Tiger Beetle implementation of this database. Tiger Beetle is actually structured kind of like a database building toolkit. And that file, tigerbeetle.zig, is essentially the configuration of the general purpose state machine. So let's look for create transfer result. Okay, so no docs here immediately, and you can see that you can see this. These enums have been maintained over time, right? These numbers are not sequential, so these numbers get added, but semantically import event belongs up here, not way down here, and so you can't really translate this by hand. I mean, you could, but it'd be bad. So there's a lot of machine translate, a lot of code generation, like custom code generation in Tiger Beetle to splat this out as C headers or Go bindings and things like that. And likewise in Rust, our Rust bindings are going through 2 layers of code generation. There's some handwritten Tiger Beetle specific code generation to generate the C headers. And then we use Rust bindgen to go from those C headers to Rust definitions. And then we write a handwritten layer of APIs on top of that have to match exactly the 2 levels of generated code that all lead down to the original source of truth here in this zig file. But anyway, none of these are paired with human readable explanations, although you can see these are all named very clearly, so maybe nobody has actually written any tedious human description of these because it's kind of not necessary. But for the purposes of the Rust API, we do have to write something in humanese here. And I'm wondering if there's, so some Rust macros like this error derive have ways to say, like, take this variant and do a mechanical transformation from, in this case, camel case to something different. So there might be, like, some derives might be able to tell you, I'm thinking of Serity in particular, the serialization library. Serity will let you say, like, well, when we serialize this, I don't want it to look like Rust. I want it to look like a snake case or something like that. So I'm just kind of wondering, before I dive in and do all the data entry here, like, is there some macro we can use to say, convert this to this? Because this looks so unmaintainable. I mean, these are never going to change. These are pretty set in stone, the names of these, because it would break a lot of APIs. So maybe it's not too bad to just by hand to duplicate that like that. but I I'm just feeling a lot of dread right now. I want to go back and look at the thiserror APIs one more time and see if it has any accommodations for this type of thing, but I suspect it doesn't. And again, thiserror is a big macro. It's special kind of macro, a derived macro. And these are all just internal DSLs that use Rust's own internal DSL, its attribute language, which I designed, to implement some kind of custom thing. And so whenever you're dealing with one of these macros, you have kind of no intuition to draw off of. You just got to read the examples to understand what they're capable of. And just today I saw on the Rust Reddit, people were complaining about the clap, the very good CLI command line parsing library for Rust. Clap is also a derive, and it's just got this huge sprawling DSL, and the only way to understand it is to basically copy paste from examples. Every time I use clap, I either copy paste from my previous code or copy paste from the examples. There's just nobody is deep enough into clap to just know how to use clap. Thiserror is not nearly as vast as clap, though. All right, here's some examples of using error. So this is interesting. Here's some ways to just like splat data directly out of the variants, but this is for like internal fields of the variants. So these variants had fields, we could just serialize those fields, but they don't. Display implements generated for your error if you provide error messages on the struct. On the struct. So you could just, on the struct, but we have an enum. Each variant of your enum. So each variant has to have an error for it to automatically generate display. We don't have to automatically generate display. We could come up with some other mechanism to automatically generate display if we wanted to. And in fact, we could go like crawl Rust crates. I don't know of a crate that does this, but go find a crate that will implement display for variants by doing that kind of textual transformation. I don't know if such a thing exists, but it seems like the kind of thing that could exist. And, whether it's worth pulling in for this task, pretty debatable. Because like every little obscure crate we pull in, maintainers are going to have to go look up and understand what it's doing. Again, we don't have any internal fields to our variants. Error transparent. Yeah, nothing here relevant that's going to just automatically make this easier for us. For the sake of fun, let's just go explore the crate ecosystem and find out if there's anything that will do this thing that I'm feeling like we're missing, which is automatically convert variants to a display implementation that has a specific reformatting of those variants. The way I usually do that these days is with ChatGPT. In Rust, I have a error enum filled with variants. Like enum, my error, this is an error, this is another error. I have no idea if we're going to find anything or not. I need to implement display for this, but don't want to do it by hand. Is there a derived macro that will transform each? These are all unit variants. Unit just means it has no arguments. There is a derived macro that will transform each variant into a string, applying some text transformation. E.g., this is an error becomes this is an in display format is called. So I wrote that very explicitly. We'll see if it figures it out. ChatGPT thinks there's a solution for this. ChatGPT is generally pretty good at Rust. Pretty bad at Zig, pretty good at Rust. Wow. Interesting. So ChatGPT thinks this is exactly what we were looking for. I'm kind of excited about that. Let's just go try this out. So we're going to go to docs, Strum. I feel like I've heard of Strum before, but don't know if I've used it. Let's see if this has been updated recently. Oops, that's not the right thing to click on. Let's go to the GitHub. Yeah, this is maintained. And it doesn't really show. This is how we're going to import it. So we're going to import it and turn on the derive feature. That suggests that this is a pretty old crate because you used to have to kind of like keep macros in a separate crate and import them in a special way. And after Rust improved enough that you didn't have to do that, for backwards compatibility, a lot of crates ended up saying like, well, if you turn on the derive feature, you can just get it from the main Strum crate. You don't have to import Strum macros. This looks like what we need. We want to derive display. And then we can say, I don't really want to write a rule for every single variant. I would just write to say for the whole enum, do the same pattern over and over. And this doesn't really look like what I'm looking for. This does not actually look like what I'm looking for. I didn't read what ChatGPT said close enough, and this is just forcing me to retype out the actual display string. Does not automatically convert camel case, but it allows you to customize behavior. All right, there's definitely a rabbit hole that I don't want to go down anymore. We're gonna do it the hard way. All right, buckle in, chat. We're gonna be in for a lot of typing. Going back to the code. Actually, I'm just gonna step back and chill for a second. Gotta really brace myself for all this data entry. And how about I play a little music for us? Let me know if you're annoyed by the music or not. It's just gonna be looping forever. Also, I can jam a little. But I'm not going to jam right now. I think this is what I'm going to do. I'm going to do this for every single one of these variants. Because these are actually, these are written to be self-documented, right? I don't feel like it really adds much to try to think hard about these variants and explain them any further than they're already explained. But for the API's sake, they have to have a human readable thing. All right, so I'm going to go ahead and use my Emacs and capture this in a register, which is Control-X-R, Control-X-R, S. Save to register. So then I can go like that. No, not like that. Anytime I have to think about what my fingers are doing in Emacs, everything just falls apart. Register, save to register S, insert from register S. Okay, so now I have this captured in register S in Emacs. And I can just go back and find it. All right, linked event. This is how the stream is going to be for at least a half hour, y'all. Linked event, chain, open, imported event. There's going to be so many typos here and nobody's ever going to find them. Imported event. All right. Some kind of like Twitch bonus reward thing for anybody who finds a typo in the next half hour. Not that I know how to give any kind of Twitch rewards or have the ability to do that. Forget I said that. I have nothing to give you. Imported event timestamp. Also, I can't like chit chat when I'm doing this because my brain will not go in two directions at once. I need to use my brain to understand words on the screen. So it's very hard to talk about anything that is not the words that I'm writing. Reserved flag. ID must not be 0. I know I always feel a little guilty whenever I get on stream to like doing some kind of like boring data entry thing. But I know that's what programming, streaming, all streaming is about. A lot of boringness. And a lot of my goals for my streaming persona is to just be kind of steady and chill background noise. So just look at Bob Ross of Rust. Just saying calm exists with different pending ID words for the next half hour, exists with different timeout, exists with different debit account ID, exists with different credit account ID, exists with different amount. Almost made a typo there. I was going to owe somebody a Twitch reward of some kind. Exists with different user data. Oh no. Debit account ID. This is referring to like a field. It's not just words. User data. Yep. Can't just power through this mindlessly. Exists with different. I wonder if all these need to be. Shoot. All these need to be named like fields. And then maybe I need to do like code braces around them. I'm not going to go that far. But let's go look at what is this relevant to? Transfer result. Let's go back to struct transfer. These are the field names. So pending ID is a field. So really this should be like that. Debit account ID, this is a field. Exists with different user data 64. Exists with different user data 32. Exists with different ledger. Exists with different code. Exists. ID already failed. Flags are mutually exclusive. Debit account is also a field name. Must not be 0. Man, I'm wondering if I missed some up here. Imported event. Doesn't really look like it. Debit account ID must not be int max. I wonder if I should spell int max in some other way. Like int max. Probably not. There's not really a language agnostic way to say that. Credit account ID must not be 0. Credit account ID must not be int max. Oh my gosh, there's so many of these. counts must be different. Getting bored. Pending ID must be 0. Pending ID must not be 0. I've been working a lot recently on music. I'm not an accomplished instrumentalist, and I stopped playing music for like 15 years while I did the programming career thing. But I've been getting way into it recently. And I'm hoping that like in 10 years from now or so, for my retirement project, I'll be, good enough to perform as an instrumentalist. I'm pretty good at music production and composition. And I used to be a pretty darn good drummer. But at this stage of my life, I don't have, English must be pending. I don't have the appropriate space to host a drum set. It would be way too loud. But recently I've been getting into guitar again. I bought myself a new electric guitar in the last week. I'm definitely going to screw up some of these words while I'm talking about guitar. But frankly, I'm more interested in guitar than in code right now. Code must not be. So I've been playing a lot of music, and eventually I'm going to do music on stream. I have it all set up here to do a little bit of music on a programming stream. But I would like to, when I was younger, I gigged quite a bit. And I always liked the experience of playing music live and also recording music, being in the studio. But, at this stage of my life, I'm not good enough, and I don't have the musician network to find like a band to play with. And I doubt I will ever be in a band again. But I'm kind of hoping that like I can learn to do like sort of an electronic music set on stream and just slowly learn to do a performance on stream with just myself. Doing a little bit of, having looping for the backing tracks with some, piano playing and guitar, and maybe running the lighting also dynamically. Seems like a fun challenge to learn how to do that. Pending transfer not found. I've really been zoning out here. I don't know if I've made mistakes or not. Pending transfer not pending. Pending transfer has different. Debit is a field again. Pending transfer has different credit account ID. Pending transfer has different ledger. I do appreciate that this API has been thoughtfully designed with error cases for everything. Exceeds pending transfer amount. One thing we should probably do here, honestly, I don't know if I want to do it right now. The numbers, let me go back to the Zig code. These numbers are error codes. And it will be pretty common for developers to see these raw error codes during development. And the way I have structured these error variants in Rust, you don't get to see the code. These are assigned by the compiler, and for one thing, they're implementation detail. You're not supposed to know the codes here without some kind of additional annotations up here. but they're not the same as the actual definitions. So I think one thing we really have to do here is go back through here by hand again. Kind of curious what the bindgen generated version of this struct looks like. Probably we got to go through here by hand and assign the correct numbers to every one of these. And then if we do that, we're going to have to write a test that like looks, introspects the zig code or the bindings code and does a comparison of every single variant with every single upstream variant to make sure the numbers are exactly the same and stay exactly the same. That's definitely something we have to do. In fact, I'm going to go write a to-do right now. Assign code numbers. Assign error code numbers to every error variant. Add tests. Yeah, I think these have to be the same as the underlying numbers. One thing it might be useful to do is make sure that we can do that by making sure these are actually U32 representation. Right now, they have an undefined representation because we haven't told Rust that we want these to actually be a U32. Yeah, let's not yak shave too much though. Well, let's yak shave a little. Let's look at what the bindgen version of this struct looks like. So far, I've not wanted to expose any of the automatic bindings to the API because they just don't look well crafted. They look like generated code. But let's go look at the bindgen version of this struct. tbclient.rs, generated by bindgen. I think it's going to have a terrible name like tbcreate. Oh, it's not even a variant. It's just garbage. It's just garbage. Yeah, completely unusable. If we go to the tbclient.c or .h, tb create transfer. So here is a proper C enum. So probably what we'll end up doing in Rust is writing a test that parses this header file and parses this struct or enum and then iterates over all of these numbers and then does like a round trip conversion back and forth between all these variants. Make sure that the number of variants here is exactly the same as the number of variants here. And maybe even, it's going to be ugly. It's going to be ugly. But for the sake of a beautiful API, it's the kind of thing you have to do in this situation. We could write a code generator that does exactly what we want and generates a custom code generator that generates, exactly what we think is going to be the most beautiful surface human API for this. That seems doable. I don't know if I like that though. In general, I like code written by humans, written by hand. If we can have this look beautiful for future maintainers and then just have a test that confirms that it's been handwritten correct, I generally often prefer that. Because if we generated this struct with a code generator, it would be kind of hidden from the maintainer. They wouldn't really get to see it when they're coding. And here it just looks like normal code, but it's super brittle. This code is very brittle. Without a test to confirm that this is exactly the same as this, it's going to be a maintenance disaster. All right, let's get back. Stop procrastinating. Pending transfer has different amount. Pending transfer already posted. There's a typo. You didn't catch it. No Twitch rewards for you. Pending transfer already voided. Pending transfer expired. Imported event timestamp must not regress. Imported event timestamp must post date debit count. Just give me 1 second. I want to confirm this chord is a C minor. I was just reviewing this this music and surprised by the chords here. It modulates from A minor to C minor, just a loop in A minor to a loop in C minor. But C minor is not in the same key as A minor. Don't know why I did that. I mean, it's just a modulation. I'm talking like I know things about music. Post date credit account. Imported event timeout must be 0. Debit account already closed. Checking my stream, make sure I still have the code up. Credit account already closed. Overflow debits pending. Overflow. I'm wondering if these are field names. Let's go back to my struct transfer. Doesn't look like it. Credits pending. Oh, I feel like it's a field name on account. Debits pending, credits pending, yeah. Overflow, debits posted. Overflows. Oh, I typoed all of these, y'all. Overflows, credits posted. Overflows, debits. That's a field name. Overflows, credits. Overflows, timeout. Overflows, exceeds credits. Exceeds debits. And this, so this I added, this is not part of the original error codes for this error variant, error enum. I added this because we don't have those tests in place to ensure that this exactly matches the underlying code. So we don't know if maybe there are other error codes the server could return. So for now, we have like an unknown error here. But once we write some airtight unit tests, we can just get rid of this and assert that we always know exactly the full set of error codes. And this we can say, I think that will splat the 0 field into that, I think. Anyway, we've written all of the variants here. And it says create account result cannot be formatted. Didn't I just implement display? What did I do wrong, y'all? So my understanding was that if we had this specified for every variant, then this error derive macro would implement display for us. What have I done wrong? Let's see, are there any other error messages? Create account result 413. Oh. Different error. Derive. Okay, that works. Hello, Steel Tormentor. If you've just joined us, you've joined us at the most boring time. I'm doing data entry right now. I mean, I don't want to discourage you from hanging out, but I am taking these error variants and making them, fully nice for the actual final API. And what that involves right now is taking these identifiers and translating them directly into human readable strings. Very boring stuff. I looked for some way to automate this in exactly the way I want to do it, but it doesn't seem to exist. But now we can go derive this error on create transfer. I've also been very bored and have been talking about other stuff and jamming on my keyboard. This error. All right, this one right here. We need to do the same thing here. What code are you writing right now, Steel Tormentor? I really like that idea of just like listening to other people writing code while you write code. Like, I've never done that, but it's interesting prospect, because I'm always listening to something while I write code. I'm usually listening. I'm going to take a break. Before I dive into this giant variant and start doing more data entry, I'm just going to take a little break. So usually when I code, I'm listening to like a streamer podcaster on YouTube with a video attached, but usually not about code. Usually something uninteresting, like video game. Well, not uninteresting, but unrelated, like video games or movies. And I always appreciate just hearing people chit chat, but I really usually like hearing like two people who like have a good rapport. It's like two old friends just chit chatting about something they're passionate about. And I don't think I'll ever be able to do that myself because I have no friends. That's not true. I have some friends, but they're not here. And also like don't have like a shared topic to talk about constantly on stream. And also pulling somebody in all the time to talk to on stream would be unappetizing for most people. Most people don't want to just talk on stream all the time. But we might like have Alex on this stream sometime. Alex Kladov, Matt Clad, the Rust and Zig personality. He's a Tiger Beetle employee, very smart guy. Steel Tormentor, are you doing Rust? Oh, some C, particle simulation. Why C? I do understand why a lot of people still like C. There's just nothing else quite like it. Even Zig is not, for a lot of people, Zig is a good substitute for C, but Zig still doesn't feel like C, really. A lot more than Rust does, for sure. I really feel like there's still plenty of room in the market for someone to come up with something simple and C-like that feels like C, but without all that baggage. I don't think Zig is quite that. Like Zig is kind of I'm not going to say magical, but the comp time stuff, the generics in Zig are kind of a step beyond what a lot of people are looking for from a low level close to the machine language. I've done a little bit of SIMD programming myself, but only with Rust intrinsics. I've never done any SIMD programming in C, Tormentor. I agree with you. I'm glad you love them all. I'm always so disheartened when I read language wars online. Like, I'm a language enthusiast. I like languages. Programming languages, not human languages. Especially in the Zig subreddit. They're obsessed with Rust in the Zig subreddit. Just got a real chip on their shoulder about Rust. Linked event. Linked. Okay, I'm back to data entry. At some point I'll do more Zig programming on this stream. I know there's not like enough people showing off Zig in the world, and it needs more evangelists. Zig needs more evangelists. Alex has been a great evangelist for Zig. He's so good at explaining technical topics. Imported event timestamp. I'm going to shut off this music for a while. It does get very repetitive. Imported, just made a typo while I was thinking two things at once. Imported event timestamp out of range. Yeah, lots of languages can exist in my heart at the same time. I'm learning Prolog right now, and I'm learning Prolog right now as a stepping stone to learn some of the more advanced successors to Prolog. I don't know if I'll ever get there. Anything that's not an imperative language is pretty tough for me. Imported event timestamp must not advance. Hi, Euler-proof. Yeah, oftentimes the best language is the one that pays the bills. I hear PHP is pretty good these days. I don't think I've ever written PHP. If not, it was a long time ago. Jay, are you at Facebook? Just when I think of PHP, I think Facebook. Thank you, Tormentor. You got me again. Got me. How long have I been sitting here coding? Anyway, I was just typing words. Doesn't really matter. The actual coding here is not very interesting anymore. Exists with different flags. Exists with different, this is a field name, user data 128. Exists with different user data 64. Exists with different user data 32. Exists with different different ledger. Yeah, I should Fergus. Unfortunately, I can't check it out right now. Fergus.com exists. Flags are mutually exclusive. Debits, this is a field. Pending must be 0. I need to come up with some more variations on my interstitial jam music. It's too boring, must be 0. Credits, pending must be 0. I'm really practicing doing two things at once right now on the stream. Talking about one thing while also letting my fingers do data entry. Ledger must not be 0. Code must not be 0. Oops. Imported event timestamp must not regress. You can tell that this error code was added at a later date to account for something. It's kind of unrelated to all this other stuff. Have an imported event timestamp bug. Need an error for that. This is going to be error. Let's see, what did we write for the other one? Just copy that. Okay, let's type check that. And then we'll go ahead and run our test suite again, such as it is. Put on some music while we're compiling. Turn off the music. Cargo test. And then I think we can checkpoint our work. And let's keep going. So we did the yak shave, and now we're popping the stack back to replacing anyhow errors with this errors. And the first function we were looking at is handle message. So again, right here, we have another case where we punted long ago. This TB packet status is another error variant. My partner is learning database development right now. She's very excited, which I'm happy about. She's learning how to do things like data migrations in a SQL database. And I'm excited for her. I haven't written code that interacts with SQL in quite a while. But I always dreaded database migrations, writing the database migrations. That's a thing that I always dread, is like the living nature of a database. You know, earlier in my career, I worked on those kind of like live systems, distributed systems that had a database that just had to keep living forever while mutating, like the ship of Theseus. And that's a challenging problem. It still seems to be kind of unsolved. I mean, I don't know anything. I haven't written against SQL databases in quite a while now. I don't know anything. That's a mantra. I don't know anything. TB packet status. All right. There's another variant here. TB, another enum somewhere. Mercifully small. So we need to go create something to represent the TB packet status now. So let's go up and try to follow some kind of... Jay, are you using an ORM? I have not. I used an ORM long ago for several projects, several corporate projects. And yeah, I don't use ORMs anymore. I told my partner, don't use an ORM. Just too much abstraction, too much leaky abstraction. But Jay probably knows a lot more about it than I do. So I need to database internals. She's actually reading The Design of Data-Intensive Applications, and she's loving it. I've heard of that book, and I've heard it's very good. And she's super into the design of data-intensive applications, which I'm happy about. My bookshelf is filled with programming books that I've read 50 pages of. So what I want to do here is I want to keep the organization of this code similar to the organization of the underlying code. So I have create transfer result on the Rust side and then on the C side here. And this TB packet status comes some point after that. I'm seeing all kinds of C structs here that I don't have definitions of. Yeah, I've already kind of organized my code slightly differently than the Zig code. That's okay, though. I have kind of the data types and the error types separated, where theirs are kind of interleaved, like data structures and then error variants are all kind of intermixed. Anyway, I'm going to put my new error variant down here, or error enum, after my other ones. And to do this, at least there's only a few of these variants. And again, so you can see the underlying enum here for errors includes a TB packet OK, but in the Rust world, we're handling that with a different structure, so we're not going to duplicate that variant. We use the Rust result type, which encapsulates the OK as a separate type. So we're just going to copy these definitions. And then we need to rewrite these in a way. I'm wondering why I didn't keep the numbers before. I wonder why I didn't think of that. I just should have assigned these to the numbers while I was doing this type of copy paste. Now I'm going to have to go back and visually correlate all the original error codes to these Rust variants in the future, not now. All right, I need to get all these formatted the right way. So replace this TB packet underscore with nothing and get rid of all these numbers. I know I said I wanted to keep the numbers, but since we've already discarded them in all of our other enums, we're going to stick with what we're going to lie in the bed we've made for ourselves. How do I want to do this? Too much data. Client evicted. Client release too low. What does that mean? Client release too high. Client shut down. Invalid operation. Invalid data size. And now we also need to write the human versions. Too much data. Client evicted. Client release too low. Client release too high. Client shut down. Invalid operation. Invalid data size. Let's type check. All the logic lives on a model. Sorry, stream. I was just reading Jay's comments. But not in a way that was entertaining. Just mumbling to myself. What did I do wrong here? Something I did very wrong. Oh, that's not the right name for this struct. Packet status. Interesting, the naming here is not result or error. It's a status. This is a little inconsistent in the Tiger Beetle API, it seems like. Like this is a result of submitting a packet. And elsewhere, the API calls these results. In Rust, we want to call these errors, but we're keeping the same naming for easy correlation of the Rust code to the Zig code. So this is called packet status and not packet result like we might expect. Okay, that should check. Starting to run out of steam, chat. Let's see, it's been 2 hours. Yeah, I don't think I've ever made it more than 3 hours on stream. Okay, now we have a packet status here, so we can go finally, popping the stack again. We can go change that handle something, handle message. This should be, I call this any result. This is going to be a result of either that thing or a packet status. And then here we have to do a conversion from, oh no, how do we do this? TB packet, how did I do this in the other cases? So this is not, there's no data type here that we can just put a conversion on. These are just integers. These are just integer error codes. Packet status. Let's see what this field is on packet. This is going to be in tb client.rs, tb packet, something, this is tb packet. Yeah, it's just a U8. How How did I do this conversion elsewhere? Create transfer result. Well, let's go look at, we have a whole module just for conversions in Rust. Create transfer. Oh, interesting. Other.result. Create. All right, what is, so there is a type here, a corresponding type here. Let's go back to the bindings code. TB create transfer. Ugh. Interesting. A little bit of a semantic mismatch here. I don't know how I feel about what I've done. So I created a conversion from this transfer result type to this transfer result enum, but they're not equivalent types. This C or zig TB create transfer result is a struct of which one of the fields is this C enum that represents a transfer result. I'm not sure. Not sure what I was thinking there, honestly. And in this case, I don't have a similar struct to hang this from implementation off of. In the C world, there's actually an enum. There's actually an enum defined, but in the bindings, it's all just integers. Not sure what I want to do about this. Not sure what I want to do about this. I kind of am thinking like maybe I'll define like a little single purpose unit struct just so I can define a from implementation on it. I kind of don't want to create a ad hoc function for doing a conversion like this. Not super happy with what I'm seeing here. Not super happy with this. All right, let's go back again. Remember what type we're dealing with here. I'm gonna probably, gonna wipe this out. We're not this far along yet. So we have a packet status, and in the bindings, we don't have a corresponding type. It's just an alias. In the C header, there is a type. So what I'm kind of thinking here, let's just spitball. I kind of want to keep the similar pattern going. So what I'm kind of thinking here is to create a little temporary private internal type just to wrap an enum in just so I can write this from implementation. Yeah, I'm not loving this at all. So like over here, I could say struct, and this is not pub, just struct C packet status of probably a U32. And then this is just serves no purpose except to wrap that integer so I can call a from implementation on it. I mean, I could also just say from U32. I could also just say from U32. There's not a whole lot of difference there. Yeah, it's not worth defining this thing. It'd be a little more visually understandable here. Nah, it's not worth it. I'm just going to do it directly from the integers. So this is not a create transfer result. This is a packet status. Packet status from U32. Packet status. And then we say use packet status star. We can import enum variants. So often these conversion functions, to avoid retyping packet status a whole lot, just do this. And again, we'll follow this pattern that we used for these other conversions. Pretty straightforward. There's the case here where we receive some integer that doesn't seem correctly typed. So that means over here on packet status, we probably need an unknown variant. And again, someday we will write some unit tests that lock this down and make this case impossible. Probably. But what impossible means, maybe not technically impossible, but probably likely impossible. Like, okay, not a digression. Like, what if this client code sees a version of Tiger Beetle from the future, and Tiger Beetle sends us an error code that wasn't in the Tiger Beetle source code at the time that this client was built? Then this client could see an unknown error code, even if we write the best unit test possible. Though also Tiger Beetle has a version to protocol, and maybe they would make it so that if error code was added, it's no longer compatible. Not sure. Don't know what the policy is there. That said, we might not be able to get away from this unknown error code thing. Like, if we see an unknown error code, do we really want to like panic? It seems like within the realm of possibility that we could always see an unknown error code. So we're going to match other, and then we're going to have a whole bunch of cases. Actually, not so many cases. All right, I'm going to swap windows here and go over to our bindings. And actually, let's go to these bindings right here. And we'll do this unknown case first. Let's just copy paste. And then here we need to copy paste. And we could probably assert that we don't see the 0 case here. I don't think I did that up here, but it would be a bug if the OK case was passed here, because we're handling the OK case differently. So really all these conversions could say, make sure we're not seeing the 0 case here. And I want to do that actually. Assert other dot, go bang here, assert other dot result. I think there's an assert in E0. Other code needs to take care of the 0 case. All right, so now we get to remove some of these words. Replace string, pub const. We'll start like that, but also this TB packet status TB packet is all so much garbage here. So much visual noise. Replace string TB packet status TB packet underscore. Get rid of all that. Replace string TB packet status equals. Get rid of all that. And now we just got to write 2. Why do these have numbers there? Are you seeing this? Where did those numbers come from? I must have accidentally done an Emacs thing. You see, every one of these identifiers has a number after it. What did I do? Yeah, I did an Emacs thing. Too much data. Just manually delete these. Oh, that's all wrong. Chat, I did it all wrong. This is all wrong. I'm confused. Let's start over. We can't just delete those idents because these are the things we're matching against. Replace string pub const. All right, so we're matching against this identifier, and all this goes away. Right. I'm just using Emacs registers here to put some placeholder syntax in. Okay, now this is too much data. Client evicted. Do I not have multi-line select in Emacs? I do have multi-line select in Emacs, but I'm not sure what you're getting at, Jay. Also, there's a whole lot in Emacs I don't know. I tend to learn just like a few commands. Oh, multi-cursor. I don't know what that is, Jay. Multi-cursor select. Yeah, don't know what that is. Emacs is very powerful, though it's really kind of fallen way behind the state of the art. I'm often lamenting that I'm stuck in Emacs. But I don't think I'll ever get up. I may get away from Emacs. Every once in a while I try to get away from Emacs, but keep coming back. All right, I think that'll compile. Looks like it's going to compile. Tiger Beetle build. So this is running the, you can see the thing that it's taking so long to do is it's running the build script again. And I don't know why. I didn't change anything that I think should invalidate the build script. That's a little frustrating. It's going all the way back to running the build script again. I probably have some directive in the build script that says like, watch this file. And then I'm accidentally changing that file. Multi-cursor select. You can put a cursor on each line and then have it repeat whatever you type or paste for each line. That sounds useful. One of the things that is very common in Emacs that I don't know how to do mechanically or by muscle memory is repeating a command multiple times. Like it's very common to say like the prefix in Emacs command with like 5, do this 5 times. But I actually don't have it's not in my repertoire. I'm going to put that in my browser window, Jay. Multi-cursor select. But I'm going to go read about it later. Let's see if this does the build. Yeah, it's rebuilding the build script, but it went fast. The build script went fast that time. Frustrating. This is just other, not other.result. Debugging build scripts is kind of impossible in Rust. You just got to figure it out. Okay, now we have enough written that we can go back again to that function and use a proper error type. Handle message. So this is no longer a result. This is a result of packet status. And then here, we're not doing this. We are saying return error of, you can probably just say packet.status.into. Let's see if that builds. I don't believe that. Oh, packet status is a U8. Huh, that's interesting. So this is just U8. Okay, unknown. There's another similar, just integer type errors. This unknown here is a U8. This expression has type U8. Oh, gross. We've seen this problem multiple times in this project where the C bindings declare just any variant as a U32. But in the protocol, they're a narrower type. In this case, the protocol says this is a U8 field, but the C variant is a U32. I wonder if the C and or ZIG code does an automatic narrowing coercion in that case. And so it kind of doesn't matter in C, but like, yeah, there's a type mismatch in the bindings. I don't know if that's a type mismatch in the original ZIG definitions or not. Easy enough to fix. Probably we'll just cast this right here. And I'm just going to use this lossy narrowing cast. Oh, this is a widening cast. That's fine. Rust integer casting is a minefield. You really got to think hard about it if you want to write correct code. But this is a widening cast, so there's no chance of losing data in this coercion. We're going from a U8 to a U32. I mean, integer coercions are a minefield in all languages. It's just that Rust kind of makes them very obvious that you're walking through a minefield. I mean, some languages, they'll just, coerce up to bigger and bigger types. Like in Python, your numeric tower will just expand to bigger and bigger types, which is its own kind of minefield, but not like a correctness minefield like a lossy coercion. All right. Oh, and now this unknown is actually a U8. So I'm going to go back and make that unknown a U32 now. This is a U32. Steel Tormentor, why do you think Zig is worse at casting than Rust? I don't disagree. I don't know, though. I only have some experience in Zig. I know they're very verbose. Like casting in Zig is extremely verbose. Even more than Rust. Sometimes. Yeah, if I were going to make a new systems language, I would think hard about numeric conversions. Even harder about numeric conversions. That's one of the big mistakes in Rust, is that numeric conversions and coercions weren't quite right. And then I was looking through sorry, I'm having a hard time staying focused on actual data entry coding here. I was reading some of the standard library documentations looking for the correct conversion. And there's even more unstable nightly methods coming down the pipeline for doing numeric conversions in Rust, because the original design was just wrong. It turns out that in Rust, every time you need to convert between two differently sized integers, you need to think really hard about what the proper behavior is. Is it wrapping? Is it saturating? Is it checked and I need to return some kind of error and handle the case where it overflows? And the built-in as conversions, even the built-in arithmetic. If I was writing a new systems language, I probably wouldn't even have arithmetic operators. They're arithmetic operators in a systems language are just kind of like misleading. Math is just not that simple as plus and minus. Like almost every time that you write any kind of numeric operation, you got to think real hard about it. And so the fact that the easy path in Rust is kind of the wrong path almost all the time. Like unless you sit and think hard, there's no possibility of overflow here. Like it's almost always just wrong to just type plus, minus, as. Yeah, if I was doing it again, I would probably make like the default easy syntax the equivalent of like a Rust checked operation where there's possibly an error and you got to handle the error for all the math. And then if you really know what you're doing, you can use a more verbose thing to say, oh yeah, this will wrap or something like that. Yeah, the zig casting. What is it about Zig's casting that is so verbose? It's not just like one, you have to call like two intrinsics to do it, I think. Like almost every time you need to provide some kind of like type hint first and then do another intrinsic for the cast or something like that. It's kind of shockingly verbose. I also don't really, in Zig, I also don't really like how the intrinsics are just kind of exposed. I really wish intrinsics were an implementation detail. But that's, I don't know, that's true in a lot of systems languages. Intrinsics kind of become part of the programming model and everybody knows about them. Even in Rust, there's some intrinsics that are just part of the API and they're kind of like documented to look like not intrinsics, but they're actually intrinsics. But I really wish intrinsics were, I don't know, it's just a matter of taste and style. But like Zig really forces people to like, you know, be aware of intrinsics. Like you use intrinsics in Zig a lot, which is maybe fine. But oftentimes intrinsics have like special powers that are not semantically possible in the language proper. Like it's just like something you type and then the compiler interprets it magically. Like there's a few Rust intrinsics where it's like not possible to express with a function, but they still look like functions. Okay, we're here, finally here. Did this work? I kind of forgot what we were doing, but it looked like this worked. We converted this packet into this status code into the correct error type. And you'll notice we didn't have to like modify any of the callers here. The callers are all kind of converting these with the question mark into anyhow results. So all we had to do was locally modify this like most bottom part of the call stack here. And the callers of handle message didn't even have to be changed, which is nice. Doesn't always work out like that. All right, I've been so distracted I've kind of forgotten what we're doing, but this all looks correct. Let's commit that. Try to accomplish a little bit more before I give up. Now let's pop the stack even further and go to collect results. I think the only possible error type here is that exact same packet status. So handle message returns a packet status error, and collect results calls handle message. So this is not an any result. This could still be a packet status error. And then there's no other error cases in this function. Let's see what happens if we build that. Yeah, not so lucky this time. All right, let's go see what the first error is. lib83. Why is this? Let's look at this error code a little closer. Couldn't convert the error to packet status. Why is that trying to convert a different error? Why is this trying to convert to packet status right here? This function doesn't return a packet status. This future doesn't return a packet status. This is, okay, this is a future. This is this future. This is an any result. So why can't, so this is a, Rx is a cancel, not a packet status. Oh, but collect results. Okay, let's look at the collect results again. There's some error types being passed to collect results. And so this needs to be the proper error type. Yeah, this is a tough error. This is a tough error right here. Hard to understand what's going on with this. The problem is there's a bunch of type inference going on here in an async function. So the result of this await here is feeding into the type inference of this collect results that is passing error types into the function and back out of the function. And the unification is just not working, and the error message is presenting. It's kind of like picking the wrong types to tell us about that unification, at least for comprehension. This would be a tough error for new Rust programmers to grok, but this is also tough code for new Rust programmers to write anyway. Collect results. Okay, so collect results takes Rust result wrapper. So this result wrapper is a generic result type. And this has to be inferred to any result here. This is pretty gnarly. So probably this packet status, this is pretty gnarly. This packet status probably want to be like, conceptually something like Rust result wrapper. There's not an associated type on Rust result. What is Rust result wrapper here? Rust result wrapper. Rust result wrapper is not a result type or not a result implementation. It's a thing that wraps an implementation. That doesn't look true because collect results is being called here with OK and error. What is a Rust result? Function. Yeah, this is actually should be called more like Rust result OK. And this is, I've been apologizing for this terrible type signature for weeks and weeks now, and now it's finally biting me. Like, what are all these generic types? I think this would be more appropriately like Rust result OK, and this is like Rust result. This is a result type. And this is the OK, the type inside of the OK variant, the payload of the result. So here we don't want to return, but I don't think I want to try to make that change now. This probably came about at some point when I actually had multiple layers of abstraction around the error types here, and probably just that name didn't change. Function of Rust result OK. I'm kind of wondering if I do want to change these. C result. Or this might also be written, again, we have this project has the semantic or naming mismatches between the Rust world and the Tiger Beetle Zig world as well. Happy Halloween to you, Mr. Prupple. It's January for future reference on YouTube. Not Halloween, but thank you. I appreciate it. This is going to break my brain for a while. This kind of problem is tough to comprehend on stream because it's so abstract. But this is not the appropriate return type for this function. Let's in fact look at our diff and see what damage we've already done to our workspace. We might want to just stop and... Oh, interesting. This Rust result wrapper. How long have I been not on my screen here, guys and gals? Sorry about that again. Do that all the time. This Rust result wrapper, it is not the final result type of collect results, let's put anyhow error here and get this to compile again. Okay, that compiles. This Rust result wrapper generic type argument isn't this error type. It is this potential error type of every individual result. So this error type is the outer error. This return type is nested and has nested results. So potential error here, and then there's potential errors for all of these. And so this handle message that is now returning a packet status is getting converted to this outer result type. And then when we call collect results, yeah, these two arguments have to do with the inner result type. This collect results is going to feed into the outer result type, which is an anyhow. This create account result here becomes this Rust result wrapper here. I am starting to think I want to rename these generic types. Rust result from C result. Yeah, I'm not really feeling like, what is the C results type in this case? TB create accounts result T. Empty result, non-empty result. Okay, I gotcha. This is tough. This is tough to read. So this last argument is where Rust result comes into play. And this is not at all what I was saying it was. This is the error payload. Oh, it's not, okay, that's why. This is not always the error payload. So this collect results function takes two prototypes of what to do when you are looking at individual results of a query. And in some cases, the empty result is a positive result, and in some cases, it's a negative result. So this sometimes, like in this case of submit create accounts, this empty result here is this OK. And so an empty result is positive. And here, this non-empty result, it's a closure. So when we have a non-empty result, this is how you convert to the final type. The final type is a result, and you convert it with error. An error here is not a value, and it's not a variant. This is a higher order function that creates a result type with the error variant. So this is tough to follow. So this Rust result type is doesn't correspond to a result type. It's more like and again, this is naming is following the underlying tiger beetle definitions. So this is converting the tiger beetle result into an equivalent Rust type, which we have named result, which has nothing to do with the Rust result trait or Rust result type. This is very confusing. This Rust result wrapper is a result. Whew. This function's bad. So I still don't actually understand why our change didn't work. Collect results. We change this to packet status. And handle message can return a packet status error. That makes sense. Then all of these result accumulator. And this is going to be an result of packet status. this could be a packet status error. Let me go back to our any result. Yeah, I'm kind of confused at what doesn't work here. This seems like the only case that this particular result will be generated is from this question mark right here. But it was showing us the error we saw was not in collect results. The error was in submit create accounts that calls collect results. And this is trying to create potentially any result, right? It's a future of an any result. And it should be possible for, so this await here is one possible error type. This collect results returns another. Okay, this is it. Oh my gosh. This would be impossible for like new Rust programmers to figure out. This is so bad. Rust is tough sometimes, y'all. So the problem here is that we have created, we're no longer returning the same result error types in the functions that are calling each other. This collect results is returning a specific error type, packet status. Submit create accounts is returning a existential generic result type, any result, any error. Anyhow is an anyhow error type. And that's fine conceptually. Like anyhow is designed to automatically coerce specific error types into generic error types. But to do that, you've got to use the question mark operator. The question mark operator is the thing that invokes all of the error coercions in Rust. And here, I'm using the question mark operator on this fallible operation, which is receiving on a channel one error type, and then collect results returns another error type. But these two can both be converted into anyhow result. The problem is I'm returning this collect results directly. I am not question marking it. So that's the whole problem. We got to do this error coercion right here. So if we do that, this function should type check. But then also we have a whole bunch of other functions that won't type check still. All these functions are doing the same pattern. So I'm just going to go ahead out on a limb and say that my diagnosis here is correct and just change all these functions to use question mark here. This is a good Rust lesson. Oh, this is not an okay. This is, can't do this. We need to actually return the value of these results. So we're going to say okay of that. Just like that. This is a really nice bite-sized Rust nugget here. If anybody ever finds this in the future in the 30 or so hours of this collection of streams. And I know that I said this is it, but almost certainly there's going to still be compiler errors we're going to have to wade through after making all these changes. This function is using a different pattern. Oh, this function doesn't call collect results. These are point queries, and they don't care about no, these are not point queries. These are range queries. Yeah, the range queries don't use collect results. The point queries use collect results. Anyway, that looks like everything, but let's go see what, oh, hey, that's good. That's awesome. So I turned my brain into the Rust compiler and figured out what it was doing wrong, and I fixed that bug. That's a tough one. Okay, so these, something this suggests to me now is that these more complicated queries that have to call collect results, these have at least 2 error types here that all have to be kind of merged together. So that's probably going to require a lot more boilerplate to figure out. So the next step is probably to handle these that look a little simpler. Because what's going to happen here, as we're making all the error cases explicit, is that, for example, this submit lookup transfers, all of the possible error cases that feed into this function have to be propagated upward back out of the function again. And we can see there are seemingly 2 error cases. There's this failed receive, and then there's this failed collect results. And this failed receive is probably something like canceled, like the other end of the channel closed. And then this is the thing we just wrote with the packet status. And so in order to create one single error type here that can handle both of those cases, we basically have to create a new error type that has 2 variants, and like one contains the message failure case, and then one contains the packet status case. So we'll have something like, I'll just write this in line, enum lookup transfers error, and one will be I'm just going to make something up. We're not keeping this. And then this will contain like an MPSC error, whatever this is called. This lives inside the futures library. I think we're using the futures channels. But then another variant that is a packet status, and this just contains packet status. This is the typical composition of error types in Rust. Though in this particular case, this failed receive might be impossible. We might be able to argue that, like, if the sending side of this channel never shows up, that is a bug. And if we can make that argument, then we can avoid doing this. And we can just return a packet status error up here. And the fact that there's a channel here internally is really just an internal detail of this API and the bindings. Like if we think about, like, well, what if we, implement a pure Rust Tiger Beetle client in the future? This channel receive thing probably doesn't make any sense. And if we did implement a pure Rust client, ideally we would want to have the exact same interface. Just, swap them out at compile time. So this is question about what to do here. I am kind of feeling like this is an impossible error right here. Not entirely sure, though. Not entirely sure. I think it's impossible. Anyway, I don't really want to solve this one right now. I want to solve the easier ones first. So let's go down to check my workspace and make sure we're still got a clean workspace. Submit query transfers. This is an easy case. Oh, well, maybe it's not an easy case. This also calls handle message. So this has the same issue of these 2 errors being potentially the same error. Or, sorry, these 2 different errors that need to be merged into one error, because handle message also is the origin of that packet status error. This is making me wonder, like, if we make this right here a result of packet status, is that future-proof? Like, is this the only type of error that we're ever going to see in the design of this API? I kind of wanted this to be like I'm thinking about like maybe this is like a custom send error or something like that. And packet status can be, one of the variants, and we mark it as non-exhaustive to leave us the ability to expand to other error variants in the future. Yeah, I'm kind of not loving the idea of just exposing this as the error type for all queries. Like we could do something like query error, or not packet error. Packet is still too specific. And also I don't want to innovate too much here. I want the Surface REST API to closely mirror the Zig API. But I'm kind of reluctant to just put packet status here. And in fact, we probably can't. Let's try it though. Let's try just making this error packet status. It's not critical right now either. Like this is not the final version of this API. And we can hypothesize that this case is impossible. You can hypothesize that this case is impossible, that the sender is always going to show up. I mean, it's really necessary for correctness that the sender shows up here. If the sender disappears, then we're going to leak a bunch of buffers, because this whole FFI involves handing ownership of buffers back and forth across the FFI boundary. And this is how we get those buffers back. And we've carefully constructed the way the callbacks here are structured, so that at every moment in time, somebody is responsible for those buffers. Like even if this message gets lost in transit, like even if the receiver here on this side disappears, those buffers will get freed. We've structured the code to make sure that happens. But if the sender never even shows up, which means that the underlying TB client library didn't give us a callback for a particular request, those buffers are lost. And structurally, I think we made it impossible for that case. So what I think I really want to do is just say this, we're not going to surface this in the API. This is just not a possible error. So I want to say expect or just say that. Expect the channel. I think that's good enough. And let's go ahead and do that everywhere. Forget, let's clear our workspace and start over. Now that I've figured out the next incremental step I would like to make, let's do that one thing at a time. Let's make this error impossible. And generally for an error that's impossible, you want to call .expect and give some kind of textual reason for why it's impossible. I have a lot of feels about the expect and unwrap APIs, although I wrote the unwrap API. I gotta stop saying that. Though I did write unwrap. The dichotomy between unwrap and expect is just not expressive enough for anybody to understand what the original coder was thinking here. But we're going to say expect, so people are going to say like, okay, this is impossible. No errors are possible here. Let's go find all these RX awaits and expect channel. And let's copy that into a register. I think I copied that register. Yeah, there we go. Find all these receives. All right, let's see if this still builds. Okay, that still builds. Now we don't have to think about those error cases and the errors we expose to the API. Yeah. Yeah, one of the problems with unwrap J is that it's just like the easiest thing to do. Instead of thinking hard about errors, writing unwrap is just too easy. And in general, in language design, and often in language design. You want to make the simplest syntactic thing the easiest thing, and actually thinking hard about errors is pretty tough. And it's gotten easier and easier over the years in Rust. But for a lot of cases, it's just like, I just don't want to think about this right now. I'm going to write unwrap. And then you think about it a little harder, and it's expect. I don't know. In some sense, just error handling is just hard. Like, it's just hard. Trying to get back to my expect. Okay, now let's again go to this simple case and see. I think now we can probably just change all of these to return result of packet status. Oh, not like that. Packet status. And I think that will check just like that. Oh, here's another. Oh, wait. Where are you? Oh, it's right there. I missed one. Expect channel. Okay, so that does check. And our test, I think, still type checks. There it is, rebuilding the build script again, rerunning the build script again. I wonder if it's because I keep switching between configurations and it needs to rerun the build script for different configurations. Yeah. Yeah, error handling's hard. Like languages that use exceptions, it's very attractive. And there was this big backlash against checked exceptions like 2 decades ago. And now the zeitgeist is checked exceptions bad, right? But that's all based on like the common experience with Java checked exceptions, like one implementation of checked exceptions at one point in programming in history. And now like checked exceptions are taboo. But at the same time, Rust's error handling strategy is very similar to checked exceptions. Like the mechanism is different. They're not exceptions, but they do involve, like at every step of the call stack, explicitly enumerating all of the types of errors that could lead into this function. And Rust's error handling is often considered like best error handling. But the similarity to checked exceptions is pretty close. Like every interface, every method signature has to say like, these are all the possible errors that could ever feed into this function. And in Rust, for convenience, we often simplify that and say just wrap them up in any error. But then like we're doing now, when it comes time for production, you kind of unwrap all those errors, unroll all those possible errors into, the full checked error types. So like the deeper and deeper your call stack, the deeper and deeper your error definitions get, just errors of errors of errors of errors of errors. It looks, in effect, very similar to checked exceptions. And it makes me think like, well, maybe I actually do like checked exceptions, and I would like a language that had another stab at checked exceptions. I do love checked exceptions don't have the very nice thing of having the call site do some explicit syntax. This is something that is like in Rust, the question mark operator. Like having some kind of call site admission that there is something bad that might happen here, I think has become kind of accepted as a best practice in language design these days. Like, don't just let the exception appear out of nowhere. Like, this is a little cut where an exception could arise. I think that is a very good practice. Just some light way to say, like, this is where the exceptions might happen. Hey, thanks for joining us, SteelMinter. I really appreciate you showing up and participating today. It means a lot to me. Have a good one. I'm going to have to go soon, too. This has been a pretty long stream. But I'm going to see if I can get a little further in this with these errors. Cheers to you. I think this will compile. Oh, I already compiled this once. Let's keep going. I think all of these will compile now. Okay, this is packet status. I'll probably just do type check them all as I go. Packet status. Oh yeah, let's type check that one too. Oop, that one didn't type check. I typed the wrong thing. Packet status. This is a result of, I really do not like these colored bracket matching things in Emacs. I just cannot visually distinguish them from my actual cursor point, and it looks like my cursor is jumping around. It's tough. I don't like the way that it does this highlighting. I know there's some way to disable that, but I do like some amount of bracket matching. Just the implementation right here, just confusing for me. All right. I think that's right. Let's check that. Nope. Expected. Yeah, I typed the wrong thing again. Right. And like one of the things that I think everybody has admitted recently is there are kind of like multiple classes of errors / exceptions. And like Rust has two classes. There's errors and then there's panics, which are exceptions. They're just kind of demoted in importance. And Java has two classes with the checked exceptions that nobody actually uses anymore. And I think it's pretty important for certain types of programming languages to acknowledge that there are, errors that matter, and then there are errors that are just throw your hands up and let propagate. Even in Rust, like there's two classes of errors, but they're kind of sometimes feel like there should be three. Like for the most part, you're just question marking in Rust. You're saying, I don't care about this. This is kind of like a panic in that I also don't care about it. I just want it to go up, up, up. And then there are some errors where it's like callers actually need to handle it. Almost all the time, callers are not expected to like match on error variants and do something in response. And in my own code, I would say if I'm going to have an API like that where the error is something you actually need to do something about, then I'm going to define a custom type for that and force them to match and not do the result thing on it. It's kind of like three. Maybe it's not even considered an error then if they're forced to respond with some kind of code pattern to an error. But almost all the time, you're not actually doing anything in response to either an error or an exception. You're just letting it go. In Rust, at least. Jay, I have to admit that I have not fully internalized Tiger style. Right now, for me, it's kind of like a know it when I see it type of thing. Like I know that I'm not writing Tiger style, and I expect this code to have a lot of iteration and review because I am not really fully internalized Tiger style yet. But I do appreciate, one, having convictions about style and coding guidelines. A lot of projects don't have coding guidelines or don't enforce them. Tiger style is enforced pretty hard. Though the bigger a project gets, the harder and harder it is to like hold the line and enforce style. I also appreciate that Tiger style is somewhat against the grain. Some of the things that in Tiger style are like anti-abstraction, right? Just show everything. Bring it all to the front and make you show everything, which is kind of against my tastes. I like to like abstract things, but I do recognize there's like a fine line, right? Sometimes it's too much, sometimes it's too little, and it's a matter of taste as well. But like for me, like once I got like a unit of code that all works together, I'm like, I don't want to see it anymore. Bump it down to another module and let's never look at it again. But Tiger style is more like, make everything flat, expose the details, but make all the details like pretty. That's my paraphrase of Tiger Style. You can tell me if I'm completely wrong about Tiger Style. I should go read the Tiger Style Markdown again. I do try to like toe the line. I mean, I'm not a company man. I haven't been employed by a big corporation in quite a while, but I do want to be supportive. Like Tiger Beetle is a very small company, and I kind of agree with the mission, and I really like Joran, the founder, and I guess he's the CEO. And I do kind of want to, like, you know, be supportive and toe the company line in this respect. Definitely assertions everywhere in Tiger Beetle, yeah. Yeah, oftentimes Tiger Beetle is like fail hard and fast type of code base. Like, we're not even going to bother trying to return an error. Like, everything that could be an error is just going to blow up the whole world. Submit, look up. Oh, sorry, I'm zoning, guys. I'm really starting to struggle here. I want to get through this though. I think I did this one. I think I did this one. Let's do a type check. Okay, we're good. Yeah, I'm not going to make it much longer. Packet status. Packet status. Yes, he is South African. I think born and raised. Yeah, it's I guess Tiger Beetle is an American company. I'm not sure though, but it's definitely South African. The founders in South Africa, and at least one employee is in South Africa. I have not been to South Africa, and I kind of regret it. I skipped out on a trip last year. Didn't get to go see it. Okay, this all works. Yeah, one of the big things that Tiger Beetle is oriented toward is the gold rush of banking in Africa. There's so many unbanked people in Africa, and a lot of fintech startups see that as the avenue into the market is having some kind of success in Africa, banking all the unbanked people. And so Tiger Beetle was kind of born out of that. And a lot of the Tiger Beetle's prospects are in Africa, as I understand it. Okay, I'm going to need to write a little to-do to myself about this, because I'm not convinced that packet status is the error type to return from those functions, even though that's the only error that feeds into those results now. It would kind of be more future-proof to define something else here. But also it doesn't matter that much. We can always break the API. It might be better to just be conservative and just do what the code leads to without overthinking future-proofing. Okay, I think we've gotten rid of anyhow at this point, but I'm not sure. Let me do a check here. Looks like, what are you taking so much time to do? Building that build script again. So I think we can go remove anyhow from our dependencies. This Tokyo dependency, why are you there? I think this is only supporting our main test program that we can probably kill right now. Oh, we're not done with any result yet. Okay. Haven't fully solved the problem. Let's back up a bit. Any result. Where are you hiding? Oh, I missed this one completely. This is a result of, oh, that's gross. So in this case, I left the word any result here. And remember, any result is just a type alias. But I did add the packet status type parameter, and it's still type checked. That's kind of weird, because any result is defined to have a different error type. But because it's just a type alias, it seems kind of loose about the typing. All right, there's one more any result here. Nope, there's some more. I think that'll type check too. Now there's one more. The constructor here could, okay, ugh, all right, there's one more error we got to deal with. I think I can't do it today though. I'm toast, and it's about dinner time. I'm gonna push this, and we're gonna wrap up, chat. I rebase, so we got a force push. Ooh. Okay. This was a great stream. We accomplished quite a bit, and the chat was interesting. I had a good time just goofing around this stream. So we focused, we wrote some more tests. So we have a full smoke test that tests all of the possible tiger beetle query types. And we also replaced most of the uses of the anyhow simple error handling with more well-typed errors, type-safe errors. And we chatted about some things. Pretty good. Next time, we have one more error type to do in the code. And then we'll probably write a little temporary README, maybe a little bit of documentation up at the top of that source file, but not fully API documented yet. I don't think I'm going to do that before we submit the PR. We're making incremental progress. We're getting closer and closer to a PR. But so many projects, the closer I get, the further away it feels like we're getting. I just want to get this, over with and get that step and get people to look at it. But it's taken a little bit of time to finally get over the finish line. Anyway, this was a great stream. I really appreciate everybody coming and hanging out. I had super fun. Hope to see you all again soon. See ya.